Good day, everyone. We are now going to discuss the iPhone operating system. And here is our outline for this discussion. We're going to discuss the introduction, system architecture overview, core functionalities, security features, performance and optimization, comparison between iOS and Windows 11, and conclusion. And for our team members, we have Alden Guanzon and Hanrade Lordomian, and of course, yours truly, Mendoza Christine Jade.
iPhone operating system, or commonly known as iOS. iOS is Apple's operating system for iPhones and iPads. You can think of it as the brain that controls everything the device does, from opening apps to managing your battery. It was first released back in 2007, and ever since then, Apple has updated it every single year. The newest version right now is iOS 18, bringing more features and improvements than ever before. One thing that makes iOS unique is that it is built exclusively for Apple devices. This means Apple designs both the hardware and the software, kind of like having a car that's designed, built, and tuned entirely by the same company. Everything just fits perfectly together. It is specifically designed to run on ARM processors, which are built to use less battery power while keeping performance smooth and efficient. Under the hood, iOS runs on something called the XNU hybrid kernel. This blends two systems together: Mac, which handles core operations quickly, and BSD, which manages things like hardware, files, and networking by combining the two. iOS can handle both small and complex tasks without slowing down. And because Apple controls every part of the process, users get a consistent experience across devices. Smooth performance, strong security, and the same familiar feel whether you're using an iPhone or an iPad. Move on to the system architecture overview of iOS. Now, iOS is built on a system architecture that is divided into four main layers, each with its own role in making your iPhone or iPad work smoothly. These layers are called Cocoa Touch, Media Layer, Core Services Layer, and Core OS Layer. Start from the top. With Cocoa Touch, this is the part you actually see and interact with. It manages the user interface, things like screens, buttons, swipes, and gestures. You can think of it like the steering wheel, pedals, and dashboard of a car. It is how you control everything. It also handles notifications and other features that keep you connected to your apps. Next to that is the media layer. This is where your phone processes all the graphics, videos, and sounds. Imagine it as a movie theater inside your phone. The display acts as the projector. The speakers are the sound system. These layers ensures your games and apps look smooth, animations run fluidly, and audio comes through crystal clear. Beneath that is the core services layer. This layer is like your phone's personal assistant. It manages your important data like contacts, calendars, and location information. It also connects your apps to iCloud, making sure your data stays in sync across all your Apple devices. Finally, Core OS. This is the base and the system architecture overview of the iOS. It's the engine of the device. You don't see it, but it powers everything. It handles low-level functions like memory management, file systems, power controls, networking, and device drivers. Without it, none of the other layers could even work. All four layers work together in harmony. From what you see and what you hear, to the data you store, all the way down to the hardware control to give you the smooth, secure, and reliable experience that iOS is known for.
So now let's move on to the core functionalities of iOS. So first one, we have process management. Primitive multitasking. The system can pause a running task so that a more important one can run first. So basically, the operating system interrupts running tasks to give CPU time to higher priority processes. Priority-based scheduling. Tasks are arranged based on importance, giving top priority to functions like UI updates and touch responses. It is for the smooth responsiveness of the system. This improves the security and stability of the system. Sandboxing. Every app runs in a restricted environment, limiting access to system files and other data apps. This improves the security and stability of the system. Background process management. Non-essential background tasks are paused or throttled to save power. This keeps the device running efficiently. Suspend or resume states. Apps can be frozen in memory, allowing instant reopening without reloading. This reduces loading time when switching between apps. Watchdog timers. The system monitors apps to ensure they respond properly. If an app became unresponsive, it automatically terminates unresponsive processes to maintain its stability. The next core functionalities that we have is the file system. The file system uses Apple File System, introduced in iOS 10.3 and optimized for flash storage. Make it easy to store, find, and manage data. Space sharing. Multiple partitions can share free storage dynamically, reducing wasted space. This allows more flexible and efficient use of storage. Cloning creates instant copies of files or directories without using extra space until changes are made. Snapshots. It captures the state of the system or data at a point in time for quick restoration. This allows the user to restore it later if needed. Strong encryption. Every file can be encrypted individually, protecting against unauthorized access. Crash protection (APFS) uses copy on write, preventing file corruption during sudden power loss. This ensures the user that their work is preserved. The next core functionalities that we have is the input and output management. Device driver integrated into kernel to minimize capability issues. It is also allowed the operating system to communicate directly with hardware components. Interrupt handling. The system can pause its current task to respond immediately to important signals from the hardware, such as touch gesture or camera triggers, event-driven input or output. Only processes input or output when needed time, saving power and improving responsiveness. Optimized for mobile hardware. Touchscreen latency is minimized for smooth scrolling and gestures. Camera and microphone drivers are fine-tuned for quick access and high-quality captures. This creates a fast and seamless user experience. Peripheral support. The system can easily connect and work with accessories like AirPods, Apple Pencil, and other devices. This makes pairing fast and hassle-free. Input or output queue management prevent one devices from monopolizing system's resources. So basically, the operating system manage how multiple devices use system resources so one device doesn't slow down everything else. This ensures fair and efficient sharing of hardware access.
Security features of iPhone operating system. First feature, it's security boot. At the startup, it checks the system and only run trusted software. IRM Trust Zone. Keep sensitive data in a protected part of the CPU that regular app cannot touch it. Mandatory code signing. Only app approved by Apple or any trusted developer can be installed and run, and nothing untrusted app get in. Application sandboxing. Each app runs in its own separated zone. They cannot access each other's data. ASLR address space layout randomization. Mix up and randomize memory addresses so that attack is hidden and cannot easily find target. DEP or Data Execution Prevention. Stop code from running where it should not, like in data memory. And the last one is biometric security. Face ID or Touch ID make sure only user can unlock or access private info. Performance and optimization of iPhone operating system. Hardware-software integration. iOS is built to work perfectly with Apple chip so apps and system tasks run smoothly. Dynamic frequency scaling. iOS adjusts CPU speed automatically, saving battery or boosted performance when needed. Thermal management. iOS monitor temperature and keep the device from overheating during heavy use. Background app refresh control. iOS limit background activity to save power and reduce unnecessary processing. Hardware acceleration. iOS use a specialized chip to speed up graphics, AI, and other demanding tasks. Low latency input, touches, and gesture feel instant for a responsive and smooth experience. Comparison between iPhone operating system and Windows 11 operating system. In architecture, iOS uses ARM64 for its efficiency and low power, so device lasts longer on battery, while Windows 11 uses x86 and x64 for raw performance handling heavy tasks better. In power efficiency, iOS optimizes battery life with software and hardware control, while Windows 11 prioritizes performance. It uses more hardware support. In iOS, runs only on Apple devices like iPhone and iPad, ensuring stability between devices. While Windows 11 supports many devices like desktop, laptop, and Steam Deck, giving flexibility but less consistent. In performance, iOS delivers smooth operation because software is tuned to its hardware, while Windows 11 performance depends with the PC specs. In security, iOS employs a sandboxing, secure boot, and encryption for tight security, while Windows 11 has strong tool like Windows Defender but face more malware risk to its different app sources. In user experience, iOS offers a consistent experience across device, while Windows 11 allows customization so device depends on the user setup. Best fit, iOS is ideal for smartphone and tablet because of efficiency and control, while Windows 11 works better on desktop and laptop with higher performance needed.
A conclusion that iOS is built for high efficiency, strong security, and stability on Apple devices. Because Apple designs both the hardware and the software, the system is optimized to run smoothly without wasting power, and it's easier to secure when only one company controls the entire process. It uses a hybrid kernel, smart memory management, and the Apple File System or APFS. To keep the performance fast and reliable, the hybrid kernel combines speed with flexibility. Memory management helps prevent slowdowns, and APFS both protect your files and make storage more efficient. Security is one of iOS's strongest points. Features like secure boot, trust zone, and sandboxing work together to protect users from threats. Secure boot blocks malware before it can even start. Trust zone keeps sensitive data in safe, isolated areas, and sandboxing prevents apps from interfering with each other. When it comes to performance tuning, iOS focuses on saving battery life without sacrificing responsiveness. Techniques like dynamic CPU scaling and background processes control allow the phone to last longer on a single charge while still feeling fast and smooth during everyday use. Compared to Windows 11, iOS supports fewer types of hardware, but that's intentional, limiting it to Apple devices. Fewer compatibility problems, tighter control over the user experience, and better efficiency and security, even if it comes at the cost of flexibility in hardware choices.